Good morning, girls. Okay.
Good morning.
How are you?
Good morning.
Good morning.
Good morning, Melissa. Hey, girls. Okay. Now, does anybody have any questions?
Like, I don't have questions. I just would like for you to go over some conversions again. Like,
Okay, sure. We can probably, it's okay, do so when we go through, it's okay, some of the questions for the review. Okay. And use them and say, well, okay, what would have it been if another option would have been the correct answer? Well, let's just go. So yes, okay, we can say it's okay. Page number 7. Ebook. Maybe that's okay, just the exam, or that's okay, the review. So the first question. Automobile related. They are not related. Clear? Oh, shit. Can you guys hear me?
Yes.
Okay. Okay. I have been having the same height for the last 20 years almost now. And okay, the color of my car has been changing, so that has nothing to do with that. So that's completely unrelated, right? Okay. Now, how is the age of a loaf of bread related to its freshness? Well, that's going to be inversely related. Okay. Because the older the bread gets, yes, okay, less fresh is that it's going to be. Okay. So pretty much okay, it's just some weird questions, but that's okay. Just so yes, okay. You can say yes, okay, that you will be able to just okay establish facts of okay what it means to be directly related, inversely related, and unrelated. Now we can say question number 4. Now, which of the following is an appropriate unit for area? And goes what I said was that area is going to be as okay a unit of distance. But that unit of distance is going to be squared. Okay, so directly as okay, you can exclude option A, which is seconds. Seconds, that's a unit of of time. Now, all the other units or all the other answers are units of distance. But yards is just yards. It's not squared. So that's out. Inches is also, yes, okay, still a unit of distance, but it is not squared. Centimeter is a unit of distance, but it says centimeter cube. Clear? Now this would actually, yes, okay, be a unit of volume. So had they asked volume, then okay, this would have been the right answer. Clear? Whereas option E says, okay, as square yards, which mean would have been the same as saying, yes, okay, yards square, I guess. Yeah, so that would become, yes, okay, a unit of area. Did you girls get that? Right, okay. Question number 5. Now, which of the following is not an appropriate unit for volume? Clear? So you mean that's okay, we're going to have, okay, as XYZ number of units, where all of them are going to be as, okay, units of volume except for one. Clear? So cubic miles. And when we said, well, okay, as volume could either be as, okay, things such as liters, gallons, ounces, milliliters, microliters, and so on. So, okay. It could also, as okay, be a unit of distance. But for volume, that is going to be as okay, cubed. So when you say cubic miles, 1 mile this way, 1 mile this way, and 1 mile this way. So that becomes just okay, okay, you will end up with a cube. Yeah, okay, so that's okay, 1 mile in 3 dimensions. This dimension, and this dimension. So that becomes a volume. Gallon, well, we already said that. You buy milk in gallons, you buy gas in gallons, etc. Okay. Centimeter. Okay, now don't fall for it because it's okay, centimeter, that was mean it's okay, just a plain unit of distance. If it was squared, it became area. If this centimeter here became cubed, it would become volume. So here, since it is made as okay, just plain centimeter, this is not a unit of volume. At the bottom, as okay, below that, what do we have? CM3. Okay, which is centimeter cube, or actually, it's okay, it's pronounced a cubic centimeter. Or what we mean, yes, okay, just call a CC. Okay. Pretty much, yes, okay, 1 CC is pretty much close to, yes, okay, being equivalent to, yes, okay, 1 milliliter. Now, when you look at the word milliliter, what would that tell you? We had the basic unit of volume, which was liter. So 1,000 of a liter is 1 milliliter. Did that make sense? Okay. So a liter of any, yes, okay, liquid or gas. If that is okay, yes, divided into, yes, okay, 1,000 equal parts. Each part would be 1 milliliter. Or you can say it's okay, 1,000 milliliters is equal to 1 liter. Did that make sense? Okay, and then pint. Right, okay. Usually it's okay the amount of blood that you give if you go for a blood donation. Any questions, girls? Any questions about this? Okay. So in the metric system, it is pretty much okay. It's very straightforward. You'll say 1 milliliter is equal to, and this is okay, 1. No, milli, that was 1,000 of a liter. Or this could also be written as 0.00. Okay. 1 liter. Or oh, sorry. We can go and say 1 multiplied by 10 raised to the power minus 3 of a liter. Clear? All these are the same as 1 milliliter. Did that make sense? Good morning. Did that make any sense?
Yes.
Okay. If it doesn't, say it. If it does, please let me know, okay? Now, what if I wrote, for instance, 5 milliliters? How will you write that as a fraction? Yes, girls.
Would it
All
be
these
5
was just
over
for, huh?
1,000?
How many?
5 over 1,000
5 over 1,000. Horses, donkeys,
milliliters?
milliliters. Exactly. Very good. Which is wrong. It would not be milliliters.
Oh, it's liters.
Because what you say now is, now you actually made this a fraction of a milliliter, right? That's going to become a microliter. It would have been 5 over 1,000 of a milliliter if I said microliter. Okay, so it's not going to be liter, milliliter, it is going to be liter. Clear? And the same you do here, 0.00, and you just write 5 liters. If you write milliliters, then you say, well, okay, the 1,000 of a milliliter. Okay, dear? Okay, Anna? So be watchful for your units. You don't just carry the unit over. Right, okay? Because here you have 5 as a whole. Here you express it as a fraction. This is still a fraction, or it's okay, a decimal. And the same you do here. You write 5 raised to the power, or right, 5 multiplied by 10 raised to the power, minus 3, and you don't write milliliter here. You're going to write liter. Clear? Okay. If you wrote milliliter, then it will become, yes, okay, the 1,000 part, yes, okay, 5,000 part of a milliliter. Okay. Did everybody get that? So you just don't carry over the unit. Then that would be the same as saying, yes, okay, $100 is the same as 10 cents. Okay, or something like that. Clear? Okay. Good. Question number 6. Now, all of the following are measurements of length except from. So again, yes, okay, and length. Okay, sometimes they will use the word length. Sometimes they will use the word distance. Clear? So all of these, yes, okay, options here are going to be, yes, okay, units of length except from 1. No mile. That's okay, that's a distance. Clear? Okay, inch. That's a distance. Clear? We can say millimeter, mm, right? Okay, is a distance. And what is a millimeter? That is 1,000 of a yes. Over a millimeter be? It would be 1,000 of a don't read chats.
Liter.
No. It is not liter, my dear. It's not liter. It's not milliliter. It is millimeter.
Meter.
It would be 1,000 of a meter, right? Okay. Okay. Where this is the milli, which is 1,000 of this one here. It will be a meter. Okay, which is okay, yes, a distance, or which is a unit of distance. Clear? Second. Well, okay, go second. That is a unit of time. Clear? So that's not a unit of distance. Kilometer. Okay. Is this, and meter is a unit of distance. Okay. Now, how many meters did we have in a kilometer then?
1,000.
Who was that?
Nicole.
Exactly. Okay. Because the word kilo actually means 1,000. So 1,000 meters is equal to 1 kilometer. Clear? Now you can also write this. That's okay. Same here. We can say 1 kilometer can actually also be written as 1 10 raised to the power 3 meters. Clear? Where we can mainly say, okay, this is the one, this is the one, right? Okay. The kilo is mainly as okay, just 1,000, which can be written like this, because 10 times 10 times 10 is 1,000. Clear? And meter is meter. Or if you want to, yes, okay, you can still write it as 1,000 meters. Right, okay. Then you don't write kilometer, because then you say, okay, 1,000 kilometers. Okay. So you just don't carry on the unit. That would be the same as saying, yes, okay, that 1,000 kilometers is the same distance as 1 kilometer. Did that make sense, girls?
Yes, so I have a question. So
Yeah.
we would know, so the unit is always after the number. So kilo means 1,000. So that would be the number and meter is the unit. And that's how we would know to what to convert to.
You can say that way.
Okay.
Convert to or convert from. Okay. But be careful, because that's okay if I say, you can say now 1 kilometer. That is going to be equal to 1,000 meters, right? Right, Jack?
Yes.
Good. Okay. Now you can write this in different ways. You can write it like this, simple. Or you can write it as 1 multiplied by 10 raised to the power 3 meters. Okay. But if I then said 1 kilometer is equal to now how many centimeters? Now you can mainly say, well, okay, we can say it's okay. Still 1, but it was 1,000 meters and each meter had 100 centimeters. So that's going to be as okay. 100,000 centimeters in 1 kilometer. Okay, now this could also be written as 1. That's okay, we can just do it like this, 10 raised to the power. Oops, sorry. 5 centimeters is equal to 1 kilometer. And if you want to go even further and say, yes, okay, then what about millimeters? Sorry. And this 1 kilometer here, yes, okay, is going to, yes, okay, still be okay, you see. Okay, so 1. Now you can write it like this. Let's say it's okay. 10 raised to the power, and that's going to be 6 millimeters. So you actually have, okay, as 1 million millimeters in a kilometer. Or we could have said it the other way around and say, as okay, 1 millimeter is 1/1,000,000th of a meter. No, sorry, of a kilometer, sorry, 1,000,000 of a kilometer. Okay, because 1,000,000 millimeters makes up a kilometer. But 1 millimeter is just 1/1,000,000th of a kilometer. Clear? But if we do the comparison between, yes, okay, kilometer and millimeter, no, sorry, kilometer, centimeter and millimeter, we can mainly say it's okay that 1 centimeter is going to be equal to 1 multiplied by 10 raised to the power 10 millimeters. Clear? Which means it's okay, we can then just say that, okay, as then, based on that, 1 millimeter is equal to 1 multiplied by 10 raised to the power -1 of a centimeter, which mainly means there is going to be 1/10 of a centimeter. Did you get that? Or this is just on top of your heads? Girl, not for my sake, for your own sake, say something. If you completely lost, just tell me, girls, like, okay. Or should I just go on
I'm lost with that one.
with that one?
Yeah, with the last one.
Okay,
that you
where,
did.
okay, my dear. Where did you fall off?
I don't know how to explain where I fell off at. Okay.
The beginning.
Okay, look here, girls. What did I say? 1 kilometer. Now, what does this actually mean? This means 1,000 meters. Clear? So that will mainly mean that, okay, as 1,000 meters makes up 1 kilometer. Right? Now we can then say that, okay, that's now based on this, then 1 meter is equal to 1,000 of a kilometer. Is that clear?
Yes.
Now I just want just okay, take the conversion even further and say that okay, now 1 kilometer is equal to how many centimeters? Now, what was a centimeter? That was 100th of a meter. Or we can actually say it's okay, this would be 10 raised to the power minus 2 meter. This here was 10 raised to the power 3 of a meter. Did that make sense? Right? Now, it will still be as okay. We'll go with 1. Now, what was it that we did? We actually crossed the 0 line or 0 point, right? Okay, the basic unit. Because on one side we have multiples, on the other side we have fractions. So that is going to become 10 raised to the power 5. Centimeters. So actually that's okay, 100,000 centimeters makes up 1 kilometer.
My question is, how is it not 10 to the power of 5, negative 5?
Because centimeters is a smaller unit.
So centimeters crossed over the line to go to the kilometer, and that makes it.
No. I said 1 kilometer is equal to how many centimeters? Now, my dear, centimeter, that is a smaller unit. Kilometer is a bigger unit because this is a multiple of meter. Centimeter is a fraction of meter. So mainly because we said, okay, yes, 1 kilometer is equal to how many centimeters? That's where we get, okay, yes, we can say, okay, 100,000 centimeters. Right? In 1 kilometer. It's only if we go the other way around and say 1 centimeter. If I said 1 centimeter is equal to how many kilometers? As you know, go, okay, yes. It will be 1 multiplied by 10 raised to the power minus 5.
Okay, now I get it.
Right? Why? Because, okay, now this is a smaller unit. Its worth is being expressed using a bigger unit. So what this now actually means is 1 over this kilometer is 1 centimeter. So this actually means that, okay, yes, you took a kilometer, divided it into, yes, okay, 100,000 equal parts. Each of that is going to be, yes, okay, 1 centimeter. So this actually is a smaller number because it actually is, okay, can also be, yes, okay, just a fraction. So it's a smaller number. 1 is still a bigger number than 0.00001. And that's why I say it's okay. When you express as anything is okay, using a smaller unit. If you express a number from bigger unit, is converted into a smaller unit, the number will become bigger because you use a smaller unit. Clear? Whereas you have a value in a small expressed in a smaller unit, but you want to just express its worth using a bigger unit, the number will become smaller. Okay. If at any point, yes, okay, you fall off the train, just use your currency. Say dollar is a bigger unit, $1. Okay, just one number because dollar is a bigger unit. Where you go to dimes, you have 10 dimes. Now that become a bigger, 10 is a bigger number than 1, right? Because it's a smaller unit. Dime is a smaller unit than $1. And then you can go to pennies, which is even smaller. So you get a bigger number then, right? You will get 100 pennies, which will be equal to the 10 dimes, which is, okay, where a dime is a bigger unit than a penny. Did you get that?
Yes.
Okay. Question number 7. Now list these metric terms in an increasing order. Now, girl, this is a kind of question. Okay, that's all we can say is, okay, this is the kind of wording that you will get. Now, when they say something, yes, okay, or asking it in, yes, okay, to be in an increasing order. That may, yes, okay, mean that you start from the lowest to the biggest. Clear. So what we may, yes, okay, we'll need to do here is, okay, start from the smallest unit and go to, yes, okay, the biggest unit. That's what you mean by an increasing order. Okay. So the smallest one that we have is micro. Yeah. If you go still don't remember, it's okay, micro was 10 raised, okay, was 1 millionth. Or 10 raised to the power -6. Okay, after which is milli. Now milli is 10 raised to the power -3. Yeah, okay. After which, yes, okay, we have deci. which is 10 raised to the power minus 1. After which we have deca, which is 10. You can write 1 if you want to. Here. Then we have hecto, which is 10 raised to the power 2. And then we have mega, which is 10 raised to the power 6. So that was in the increasing order, okay? Where you mean, yes, okay, start from the smallest to the biggest. Is that clear? Right, okay. Now, our next question is mainly, yes, okay, just the opposite, where they go, yes, okay, in, is okay, decreasing order. And what would a decreasing order mean? That's mainly, yes, okay, we can just say, yes, okay, that we start from the biggest and end up at the smallest. Or we can say, it's okay, count down. Here. As you go, that's okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bam! Happy New Year, right? Okay. But that's a countdown. That's mean, yes, okay, we go from the biggest and end up at the smallest. Okay. So the biggest that we have here is giga. Okay, which was 10 raised to the power 9. That was your giga. Then we have kilo, which was 10 raised to the power 3. Then we have hecto. Right, okay. Then we have centi. Right, okay. Then we have micro. And then we have nano. Did that make sense? So that's in a decreasing order, that you start from the biggest and end up at the smallest. Okay. So is everybody good on what it means? That's okay to arrange things in increasing order and decreasing order.
Yeah.
Okay. Any doubts? Okay. Because yes, okay, you can get just okay a list of okay different units. Or as okay 3, 4 options, and they will ask, okay, which of the following is in an increasing order? Which of the following is in an decreasing order? Clear? Okay. So as okay, there are different ways of okay, as you can see, as okay, asking this question here. Okay, so increasing, you start from the smallest, and you just keep on increasing more and more and more and more. Decreasing is just the opposite. Okay, so you can mean it's okay, that's right, okay, as a express that as a countdown. Okay, here we go. Now, how many milliliters are there in 8 liters? So we have 8 liters, and the mainly is okay, just ask us how many milliliters do we have? Now, girls, let's keep, right? 8 is 8. We can say it's okay, liter is liter. I just keep, yes, okay, here, what do we have? Yes, okay, this is a smaller unit. All smaller. 1/1000 of a liter. So that may mean that, okay, as 8 liters is equal to 1, or is going to be equal to 8,000 milliliters. Clear? Now, this 8,000 milliliters could also be written as 8 multiplied by 10 raised to the power 3. Did that make sense? They had to ask the other way around and say, yes, okay, 8 milliliters is equal to, yes, okay, how many liters? Then that would have been 8. Now here is okay, we went from a smaller unit to a bigger unit. So that's going to be this. Did you get that? Did you get that, girls?
Yes.
I said, okay, that's 8 milliliters is equal to how many liters? Then that would have been the answer. Or you could have written it as this. Or it could be written as 8/1000 of a liter. They all are going to be equal to 8 milliliters. Or you can say, okay, the same answer, okay, the same answer could be written in, expressed in different ways, or be asked in different ways. Clear? Now, 80. You see the option 80 as an answer, right? You see option C. That would have been the right answer had they asked about us, okay, 8 liters is equal to how many? That would have been deciliters. Had they asked you that 8 liters is equal to how many deciliters, then the answer would have been 80. Okay, because a deciliter is 1/10 of a liter. So you would actually have 80 deciliters in 8 liters. You see option D, which says 800. That would have been the correct answer had they asked you about how many centiliters we have in 8 liters of milk or water or whatsoever. Because this centi here is 1/100th of a liter. Did that make sense? Okay, goals. Any questions? Now question number 10 then. How many centimeters are there in 3 meters? Now what they go and say is, they says, okay, how many centimeters? Or let's just say, okay, that we have 3 meters. And they ask us how many centimeters. Now we can still say, okay, we can just write, okay, 3 is still going to be 3. Now what was the centi? That was 1/100 of a meter. Okay, but mainly because, okay, we go from a bigger unit to express its worth in a smaller unit. You're going to end up with a bigger number, right? So that's going to be, it's okay, 300 centimeters. Okay. But had they asked the other way around and said 3 centimeters is equal to how many meters? Then that would have been 3 over 100. Where this could also have been written as 0.03 meters or 3 over 100 of a meter. Okay. So option A would have been the correct answer had they said 3 centimeters is equal to how many meters? But that's not what they ask here. They ask 3 meters is equal to how many centimeters? Clear? Okay. 1/3 is not. And 3 cannot be the same. It cannot be because 3 meters is not equal to 3 centimeters. Then meter and centimeter have been the same unit. Clear? Now, options D as in dog, that's the correct answer because we have 300 centimeters and 3 meters. Option E as an elephant would have been the correct answer had they asked us this way, that 3 meters is equal to how many millimeters? Then you would have had 3,000. And 3,000 or option E would have been the right answer. Did that make sense?
Yeah.
Thank you. Question 11. Now, how many kilometers are there in 3,000 meters? So what do we have? we have 3,000 meters. Right, okay, and the main is okay, just ask us. That is going to be equal to how many kilometers? No, that is straightforward, girls. Oh, you have the meter. Clear? We can still say as okay. 3. And what does kilo mean? Kilo directly mean 3,000. I mean 1,000. We should have here. So 3,000 meters is actually going to be equal to just 3 kilometers. Okay. Now, had they just said, had the answer been, as okay, had the question been 300 meters is equal to how many kilometers? And the answer would have been 0.3 kilometers. Yeah. Or had it just said 30 meters is equal to how many kilometers? Then it would have been 0.03. Okay. Any questions? No?
No.
Put. Now, where is the reciprocal of 100? Now, it's easier to say as, okay, reciprocal of 100 is going to be 1 over 100. Clear? Do we have that as an answer? No. And that's because it's this. Because this is just, okay, as written as a fraction. This is written as a decimal. Okay, better view is, okay, multiply 100 by 1 over 100. Or we multiply 100 by 0.01. Well, here is straightforward. Result is 1. Here is, okay, you multiply 100 by 0.01. The answer is 1. Had they asked that, okay, where is the reciprocal of 1,000? It could have been 1 over 1,000. Or it could have been 0.001. Clear? Or if we say 10,000, it could be 1 over 10,000. It could be 0.0001 and so on. Now, do you guys mind getting a cheat? It was a cheat that my teacher, not my teacher, but our teacher gave us in 3rd grade. It can get handy. Okay. Because what he mainly said was, okay, yes, how would you know, yes, okay, what to multiply this number here with, or this number here with, or even, yes, okay, this number here with, so that, okay, yes, the product is 1. And the cheat is, for the decimal, you just write 1. And then for each number after the decimal, you just put a 0. So yes, okay, 0.001. If you multiply that by 1,000, it becomes 1. Likewise here. For the decimal, you put a 1, and then yes, okay, for each decimal number, you put a 0. So that's when you can say, it's okay, multiply 0.0001 by 10,000, gives you 1. And likewise here. For the decimal, it's okay, I put a 0. And then for each of put a 1, and for each decimal number, I put a 0. 2, 3, yeah. 6, 7, 8, 12. So this is actually, it's okay, a pico. 1 trillionth. Clear. So actually, that's okay. If I multiply that by 1 trillion, it becomes 1. Now, those of you who don't actually, that's okay, sit here and count the zeros. I just did it. It was 10 raised to the power minus 12. So actually, that's okay. We'll have to multiply by 10 raised to the power 12. Because, okay, that was 10 or 12 digital numbers. It's okay, decimal number, sorry. So that would be 1 trillion, written in pink. 1 trillionth, written in black. But when you multiply both, yes, okay. 1 trillion by 1 trillion, then it becomes 1. But that's the cheat. Okay, so at any point, it's okay, you get lost. Yeah. Any questions? Okay. And don't ask me when I was in 3rd grade. You'll be scared. Right, okay. Well, yes, okay, I still remember it. Because, okay, I have used that cheat a lot. Okay. Now, they just go the other way around and say, it's okay, what is the reciprocal of 1/8? Now, what will be the reciprocal of 1/8? If the reciprocal of 8, if the reciprocal of 8 is 1/8, and reciprocal of 1/8 is going to be 8. So simple as that. Clear? And I said 1/80, then the reciprocal would have been 80. And I said 1/800, the reciprocal would have been 800. That's how it goes. Okay, girls? Next is, how many hearts are there in 3 megahertz? Okay, this is an ultrasonic question. So we say 3 megahertz. Okay, and I hope everybody know what hertz is the unit for. Anybody remember? Anybody remember what the
Frequency.
frequency? Exactly. Very good, my dear. Clear? Now it's just a matter of saying, it's okay, what does mega mean? Well, I'm not going to sit here and write zeros. So we're just going to do it this way. This would be a mega. So what would that mean? That we will actually have this, or we can just, okay, still say 3 million hertz is 3 megahertz. Clear? Did that make sense? Now 300, or sorry, 3000, option B. 3000 would have been the answer if they had said 3 kilohertz. And that would have been 3000 hertz. Because we can still say that, okay, as 3 is 3. While, okay, as hertz is hertz. But then kilo is just 1000. Did that make sense? Did that make sense?
Yes.
Right. Okay. 333. Well, okay. That's not how it goes. Okay. And 0.003. That would have been the answer if they have asked um, 3 megahertz is equal to how many gigahertz? Then 3.003 or 0.003 would have been the right answer. If they said that, okay, 3 megahertz is equal to how many gigahertz? Because 1 megahertz is equal to 1,000. That's a little clumsy. Is actually equal to, yes, okay, 1,000 of a gigahertz. The hertz is hertz, but you can mainly say that, okay, as a mega is equal to, yes, okay, 1,000 of a giga. As you can see here. Did that make sense? Any questions, girls? Question 15. Now, how many liters are contained in a jar of 5 liters of fluid? So we have, okay, as 5 liters. And the main is, okay, just ask us how many milliliters would that be? Now we can still say that, okay, as 5 is 5. Liter is liter. By here, okay, here is going to be, yes, okay. Now this is a smaller unit. How small? 1,000 of a liter. So that may mean that we'll have 5,000 milliliters in 5 liters of milk, gas, cold drink, whatever. Clear? 5 cannot be the answer because, okay, as if 5 had been the answer, that may have been saying that, okay, as a liter and a milliliter is the same thing. It's not. Okay. 5,000 is our answer. 500 would have been the answer if they had asked us, if they say, okay, 5 liters is equal to how many? Centiliters. Then we will have had 500 centiliters is equal to 5 liters. Right, okay. And option D, which is 0.005. Clear? There they said, okay, 5 liters is equal to this many kiloliters. That kilo actually is, okay, or mean 1,000 liters. Or kiloliters would have been 1,000 liters. How? Did that make sense? So that's how the questions would have been asked to make any of these options here is okay, correct. Okay. Did you girls get that?
Yes.
Good. Now they just go the opposite way. And says, okay, how many liters are contained in 80 milliliters of fluid? So now we have 80 milliliters of fluid. And the main is, okay, just ask us, that is equal to how many liters? Now we can mainly say that, okay, yes, this milli here is 1/1000. Okay. 1/1000. Now the option that we have is 8. Okay, 8 liters. That cannot be the case. Okay. That cannot be the case because 8 liters is not going to be equal to 8 milliliters. That would have been the case if they had asked us 8,000 milliliters. That would be equal to 8 liters. I think we had a similar question like this before, where they asked about 8 liters, just other way around. Okay. So that's not the answer, because they didn't give us 8,000 milliliters. They only gave us 80 milliliters. So 8 cannot be the answer of liters. 80 liters is even more crazy, because that would have been the correct answer if they had given us 80,000 milliliters. Then we would have had 80 liters. Clear? Now, the other answer is 0.0, how many is it? 0.08. Now, some of you may be tempted to say, as okay, isn't that the answer? No, that would only have been the answer if they had if we had been given 8 milliliters. Okay, so what this here actually is okay will mean is that now you can actually okay solve it this way and say 80 multiplied by 1/1000 liters. And now that becomes 8/100 of a liter. And this now can also be written as 0.008 liters. Now you can actually put as many zeros as you want to after here. It doesn't make any difference, because all these zeros are worth nothing. It would have been a different case had we said, okay, yes, that this was a whole number. Okay. Did that make sense? So whether you write 1 0 or as okay, 100,000 zeros after this, okay, that's after this 8 here, they have no worth. Okay. So this is not equal to this. Well, just because decimal. This is actually as okay, this and these are the same. It's still the same. It's still the same. It's still the same. But it's not going to be equal to this because this is really a whole number. even if you write as okay 8 point, and then you can add as okay as many zeros you want. It is still just 8 because okay, what all these numbers here were, they were decimals. Okay. They will end up having a word if you actually now put a number here. 2, a 1, a 3, a 4, 8, or whatever. But it's okay, simple zeros after a decimal, or after a number, or after a decimal number, is not going to have any word. Okay. So that's okay whether you write 0.08 or whether you write 0.0800 or 0.80000. They all work the same. Did you ladies get that? Question 17. Now, how much bigger is 1,000 than 10? Or it can also be asked as okay, how many 10s do you have in 1,000? How many 10s? Do we have in 1,000? The answer to this question can also be asked, what number should we multiply 10 with to get 1,000? And that would be 100. Clear? Option A, which is 10 times, would have been the correct answer had they asked about how many times, how much bigger is 100 than 10. Clear? Our correct answer is yes, okay, 100. Okay. Which is option B. Option C would have been the right answer had they asked about 10,000. And 500 times would have been if they asked us, okay, 500,000. No, 50,000, sorry. Right, okay. Now, how much bigger is 1 billion than 1 million? Mickey says, okay, how many billions do we have in 1 million? Oh, sorry, how many millions do we have in 1 billion? Or how many megas do we have in a giga? And that's 1,000. Or Wikimedia says, okay, the difference between a giga and a mega is 10 raised to the power 3. Now, mainly because they say, okay, how many of the smaller do we have in a bigger one? That's going to be like this. Had they said, how much bigger is a giga than a mega, or mega than a giga. And it would have been this. Because a mega is a smaller unit than a giga. How much smaller is 100 than 1,000? And that's a tenth. Okay. It would have been 1/1,000 if they had said 100,000. Yeah. It would have been 1/. This. I thought this. Had they said, okay, yes, a million. Now matching. So that's okay. Match the appropriate term with in the first column with the units in the second column. So time. So any unit of time. Okay, do we have any unit of time? Yep. 4 minutes. Clear. So 1 is G. Okay, length. Now be careful, girls. Is 12 centimeters. Okay, although yes, okay. 6 miles is a length by the square. So that becomes, that's okay, that'll become area. Okay. Cost. That's okay, 86 cents. Well, you can't get much for 86 cents, but anyways. Okay. Volume. Now, volume could either be as okay, liters, milliliters, pints, gallons, so on, so on, so, or it could be as okay, any unit of distance, cubed. So 15 cubic meters would be as okay, a volume. Area. Make sure that you know that, okay, it's going to be any unit of distance squared would be area. So that is your 16 square miles. Okay. Test score. Okay. %83. Well, that's a little bit wrong of saying that. Okay, anyways, well, because it could have been 83 as well. 5%. It doesn't say percentage. Mass. Now, mass is what most people, yes, okay, consider weight, which is wrong. Clear? Okay, weight is just okay, the force of gravity. So mass here is going to be as okay, 14 kilograms. Temperature. That's okay, -9 degrees, which could have been more specified because that could also have been as okay, a degree angle. Okay. Okay, goals. Any questions? Okay, now just take a short 15 minutes break, and when we come back, yes, okay, we will start, okay, yes, looking at some of the review questions at the in the exam review. Okay, girls? Okay, see you then. Okay, girls, welcome back. Any questions at this moment?
No.
Okay. So let's just go to page 423. And okay, yes, we have okay some questions from this chapter here. Okay, chapter 1. Now, what is the vertical axis of a graph called? Now, if you guys remember that we said that graph mean is okay. Well, it mean to have okay 2 of 3 axes. Clear. Now here is okay the vertical. That's the red one. And that's going to be okay what we'll call the y axis. Okay. Question 2 mainly is okay, just ask about is okay the horizontal axis. And that is going to be okay the x-axis. Okay. And then we had okay the third one, which okay is not here, but okay we can still go and see. That would be okay the z-axis. And that would mean it's okay we refer to as okay as a perpendicular axis. Yeah, we'll talk more about the z-axis here. It's okay in chapter 11. But for now, it's okay. Just remember that okay, yes, vertical axis is the y-axis, horizontal axis is the x-axis. Okay. Now, how are scores of the ultrasound board exams related to study time? Well, that's okay. Not just the ultrasound board. You can mean it says okay. The more you study, the greater your scores. So where this is up and this is up, that mean that that's going to be directly proportional. Or we can say it's okay, directly related. Clear? Even if you go the other way around and say it's okay, the less you study, well, okay, lesser will be the scores. That is still directly proportional or directly related. Okay. Question number 4. How are caloric intake and weight related? Well, okay, yes. More calories intake will lead to, yes, okay, more weight. Or the other way around, less calorie intake, less weight. So again, yes, okay. That would be directly related or directly proportional to one another. Now, how is weight related to a sonographer's time spending exercising? Okay, well, if it were that easy, Wikimedia says, okay, more exercise will actually lead to less weight. Or if you go the other way around and say it's okay, less exercise will mean more weight. So that makes it inversely proportional. Okay. Is that clear? Okay. What is the reciprocal of 1000? So the reciprocal of 1000 is going to be, it's okay, 1 over 1000. Now this is mainly as okay, just expressed as a fraction. It can also be expressed in a decimal form like this. Or even like this. Okay. Now, what is the reciprocal of 5? Is mainly as okay, going to be 1 over 5. Now, please keep in mind that, okay, 1 over 5 also would be the same as saying, yes, okay, 0.2. Okay. And this 0.2 can actually also be the same as saying it was 0.2 multiplied by 10 raised to the power minus 1. If you don't believe it, then look here. 5 multiplied by 1 over 5. 5 times 1 is 5. Divided by 5 is 1. 5 multiplied by 0.2. Now 5 2s are 10. But we have one decimal number. So let's put a decimal here. So it becomes 1.0, which is the same as 1. And here we said 5 multiplied by 2 will multiply by 10 raised to the power minus 1. What is 5.2? 5 times 2 is 10. multiply by 1 minus 10, which that this actually means 1 over 10. So that would mainly mean that 10 is multiplied by 1 over 10. Is that clear? What is the reciprocal of 1 over 10? The reciprocal of 1 over 10 is going to be 10. Clear? But just keep in mind, guys, this 1 over 10 here could also have been asked as 0.1. Okay, so whether they say 1 over 10 or whether they say 0.1, this is just okay as a fraction. This will mean it's okay, just a decimal. But what it mainly meant to be reciprocal was that okay, as if you multiply them together. In both cases, yes, okay, the answer will become 1. Is that clear? Question number 9. A sack contains 6 pounds of flour. Okay. The content of the bag is increased by a factor of 5. Now goes. They say increased. And here we say factor of 5. That means yes, okay. Now I mean by increased, that's going to be yes, okay. And a factor, that means that you multiply it. Where had it said decreased by a factor. That means that you divide. Clear? Okay, but here we say okay, it's increased by a factor of 5. So that's means okay, there's going to be that we multiply this 6 here by 5. Because I think it's okay. How much flour is going to be in the bag? Okay, so it's going to be as okay 30 pounds. Had it been the same question about what they had, okay, same question, same bag of flour, but what they say is okay, it is decreased by a factor of, let's say, 3. That would mean that okay, yes, this 6 pound bag here is, which is okay, B divided by 3. And in that case, that's okay, the bag would then just have 2 pounds of flour. Okay, so this is mainly that's okay, just okay, you can say it's okay, mathematical language. Increased by a factor of the mean that okay, you will multiply. Whereas if it said decreased by a factor of, that mainly means that it's okay, you will multiply. Oh, sorry, divide. Divide by what? Or multiply by what? Yes, okay. The number that it's given here. Did you girls get that? Okay. I probably shouldn't have done it, but okay, yes. So we have a bouquet of 30 flowers. Okay, the size of the bouquet is decreased by a factor of 3. Yeah, and what did we say? Okay, it's decreased by a factor of meant. There you divided by what? Divided by 3. So we had 30 flowers, but that's not going to be divided by, sorry, 3. So now each bouquet of flowers will have a total of 10 flowers. Okay, so here it's okay, the word that's okay, decreased by a factor of 3 does not mean that you subtract. Had that been the meaning, then okay, as question answer number 27 has been the correct answer. Okay. Here, option D as in dog would have been the correct answer had this as okay, that is decreased by a factor of 2. Then you mean it as I said, okay, 30 divided by 2 is going to be, that's okay, 15 flowers. Did you girls get that? Question number 11. Now, which of the following is not a measure of area? Clear? Now, what did we say that area was? Any distance squared. So that's okay, square centimeter. That's a unit of distance or area, sorry. Because centimeter is a distance and it is squared. Okay, but that's not what they're asking. They're asking which of the one is not. We say yes, okay, meters squared. So again, yes, okay, meter. If centimeter is a unit of distance, then meter is going to be a unit of distance too. And when we say squared, it's squared. Yep. Now we say yes, okay, cubic meters. Now meter is the unit of distance, yes. But if you cube it, that becomes a unit of volume and not area. Clear? So that's okay, that's the answer, which is not a unit of area. Whereas feet times feet is mainly as okay, just another way of saying, well, okay, yes, we have feet multiplied by feet. This is actually going to be feet square, square feet. Okay, girls. Now question number 12. A sonographer measures the perimeter of an anatomical structure. Which of the following choices is a reasonable value for the measurement? Now the perimeter is meaning as okay, just going to be as okay a plane distance. Because perimeter is just going to be as okay another word for as okay circumference. Which starts from here, tick, 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 and okay, yes, if you straighten that out, that will be yes, okay, the perimeter. Okay. So 6 centimeters square. Okay. Now, that would only have been if we had measured it like, okay, like this. Because, okay, that will become an area. Okay. Jesse? 5 cc. Or 5 cc, that would have been, yes, okay, the right answer. At the ask us about not the perimeter, but the volume. Okay, where, okay, as we already said that, okay, this cc here stands for cubic. Centimeter. The cubic centimeter actually means centimeters cubed. Now 15 millimeters. And that's meaning it's okay, the right answer. Because, okay, that could have been the distance from here all around, which would be the perimeter or the circumference. But it's okay, we may straighten it out. Clear? 18 decibels or dB. Now, decibel, yes, okay, that's going to be, yes, okay, a unit. Sorry, that we will start coming across in chapter number 3. And it's going to just, okay, be popping up again and again and again and again and again. Okay. So, yes, okay. So what that is going to be a unit for, yes, okay, we'll talk about that when we get to that point. Now what, okay. Any questions, girls? But most ideas, okay, after we have talked about decibel, we can mean says, okay, it's not going to be decibel because decibel is not a unit of distance. Okay. Question 13, what are the units associated with the circumference of a circle? Clear? So yes, okay, main is okay, what we just did. If you said, okay, it's a circle like this. We call it this in the previous question, we call it a perimeter. Here we just call it a circumference. Because this mean is okay if you see from this point here, like this. Okay, so that's still going to be as okay, straight unit of distance. Right, okay. What if they had asked not circumference, but they had asked radius? Yes, girls. If you have a circle like this, what would be the radius? Anybody have a guess? I can be sitting here. I'm not going any further unless I get some kind of response. And don't say you don't know.
Is it your measurements from the top of the circle to the bottom, like the going from one end to the next?
Like you say this?
Yes, or it could be from the top to the bottom. It don't have to
At the
be-
top, okay, okay, like
Yeah,
this,
yeah, yeah.
okay.
Like that.
Okay. Do you think that would be the radius?
I'm just guessing. So I really don't know. So
Okay,
I'm just taking
no,
a-
that's fine, that's fine.
Is
It's better-
it like to the middle of the circle? Like the radius is like the middle of the circle? Like the halfway point? Like right there?
Here,
Yeah,
to where?
to the end. To the left or right.
Anyway,
Yeah,
yes,
that pink line.
the pink is the radius. Okay, girls? So if you have any circle, wherever you okay, sorry. Clear. No, probably not. Okay, it's not exactly round here, but this would have been the radius. So you can mean it says, okay, this distance is okay, is going to be the same. No matter is okay here. But that would have been the radius. Okay. Now it can't be square millimeter because square millimeter that would have been a unit of area. It can't be cubic millimeters because, or cubic centimeters, because cubic centimeters is a unit of volume. That's when you, for instance, okay, have as a third dimension as well. Clear? And m cube or m is okay raised to the power 4. Okay. So here is okay the circumference. Mean is okay, we're gonna say is okay, what had been this pi is okay, measure from here all around. Or you can say it's okay, if you take the circle and okay, straighten out the line, that would be as okay, the circumference. That would be the area, or that's okay, area that it in circles in a straight line. Now, next question. And listen, girls, sometimes you actually, it's okay, will come with come across a question where the answer is in the question itself. So here it is. The volume, and you don't even have to go any further. You already got the answer. But let's just see it. The volume of a cystic structure is estimated from a sonographic data. Which of the following is an acceptable measurement of this volume? So the meaning is okay, just know which of the following given here is okay as a unit of volume or measurement of volume. It couldn't be 6 because 6 is just a number. It doesn't really have a number. It doesn't really have a unit. Right, okay. So 6 without any unit could mean anything. Clear? 6 centimeters. Well, okay, yes. 6 centimeters. Well, okay, but this is mean that's okay, just a unit of length, which is not a unit of volume. 6 centimeters square. Now, that's okay, this was a unit of length. But it's okay, when it is squared, it becomes just okay, a unit of area. So 6 centimeter cube. And as I said, that's okay, when the unit of this distance is cubed, it becomes volume. They could have said 6 milliliters, 6 centiliters, 6 liters, or something like that. They were as well also have been units of volume. Okay. But here it's okay, you actually, it's okay, got the answer right in the question. You just have to know, it's okay, what was the unit of volume? And okay, yes, it's right there. Okay. Okay, girls. Question number 15. Now, what a bite. Now, the speed of blood traveling through a blood vessel is 750 centimeters per second. Okay, so this is the speed that blood is traveling through a blood vessel. Now you're asked to measure this speed in miles per hour. So they mean, yes, okay, just ask you how is that speed you're going to measure in miles per hour. Clear? So what information will be sufficient for you to complete your task? What do you need to know? Mainly, it's okay, just two things. That how many centimeters equals a mile. And on the other hand, how many seconds makes an hour. That's what you will need to know. Now, does anybody know how many seconds you have in an hour? Anybody? It's a simple piece of math with a cheat.
Is it 120? Oh, no.
120. Very good, Jen. Do you mind tell the girls how you got that one?
It's just like, because there's 60 seconds in a minute and there's 60 minutes in an hour. So I just did 60 times 60.
Okay, but you can do a cheat way and say, okay, 6 times 6 is
36.
36. And then you just took the 2 zeros and that.
Yeah.
Okay, so 3,600 seconds or 3,600 seconds in an hour. Clear? Okay. Now, does anybody know approximately how much a mile is?
Isn't it 1,600 meters?
approximately 1,500 meters. So 1.5 kilometers approximately. Here, okay. So that's okay, but that's mainly as okay, the two things that you'll need to know. Okay, so you can say it's okay, 1,500 meters. No, sorry. Yeah, 1,500 meters is approximately 1 mile. But then it's going to be as okay. 1,500,000 centimeters in a mile. Okay. But just okay. Although yes, okay, you saw you saw numbers and things like that, but that was mainly as okay, the two main information or piece of information that you would need. Right. So that's okay. How many centimeters do we have in a mile? How many seconds do we have in an hour? Now, how much bigger is 1 billion than 1,000? Or just asking it in another way is how many thousands do we have in 1 billion? Or also, yes, okay, what number should you multiply 1,000 with to get a billion? Okay. And you would actually, yes, okay, have to multiply 1,000,000 1,000 times to get a billion. Because if you look at the mega, which was 1,000,000, that were raised to the power 6. And a billion raised to the power 9. So you actually say, okay, we'll have to multiply this to get this. Or you multiply these two. Because this becomes just, okay, 10 multiplied by 10 multiplied by 10 or 6 times. And then another 10 times, another 3 times. Is the same as this. So you can actually say that this multiplied by this. Becomes this. Okay. But if they have flipped it around and says, okay, how much bigger is a billion, or a million to a billion, it would have been opposite. Or it would be the 1,000th of a billion. Okay. And 1,000th of a billion is 10 raised to the power minus 3 or 0.001 or 1 over 1,000. Okay, goes. The metric system, and here is okay. Maybe it's okay, just similar, just okay. That's similar to just okay what we had earlier, but they are giving us okay different orders and say okay, select the sequence that appears in an increasing order. And what did I say when we, or what did it mean by when we said increasing order? That we start from smaller and we go bigger. Clear? Okay. So you go mega, kilo. Well, okay, that is in a decreasing order right there. So you don't have to go further. Okay. You go nano, milo, micro. Okay, it's already messed up there because a micro is lesser than a milli. So I should have come before the micro. Or the micro should have come before the milli. Okay. You go centi, deca, centi, deci, deca, hecto. Okay, yeah, that looks good. Then you go milli, hecto, centi. Okay, that's F up 2, sorry. Okay, so the one that's mainly is okay, option C. Okay, that goes in now, increasing order. Okay. Any questions? Clear? Had they asked an increasing order, then okay, that's option B. No, not B, sorry, that's up 2, that's one. Okay, none of them. Okay. Question 18. Now, how many nanoseconds are there in 7 seconds? So we says, okay, we have 7 seconds. And they then ask us as, okay, how many nanoseconds is that going to be equal to? Now just keep in mind, go nano, yes, okay, that is a small unit. All small, 1/1,000,000,000. Right? Okay. It's going to be 1/1,000,000,000. So that mainly mean that, okay, yes, that we can say it's okay, you will have 7 billion. Seconds or nanoseconds in 7 seconds. Is that clear? Now, this could also be written as 7. And we can just mean, okay, just write that as 10 raised to the power 9. And now you don't write nanos. Okay, no. Okay. So that's going to be, it's okay, nanoseconds. You could also go and say, well, okay, what about this one here? 7 thousands. Now, if you write it like this, then it's going to be microseconds. Clear? Or if you write 7, and we can mean it's okay, just go and see. Then it's going to be milliseconds. Now just keep in mind, girls, that this fun here could also be written as 7 multiplied by 10 raised to the power 3 microseconds. Or this one here also has been written as 7 multiplied by 10 raised to the power 6 milliseconds.
Can you explain how, did you get the 7 micro or 7 million microseconds? I mean, how did you convert those two? Because I'm confused. I got the 7 multiplied by 10
Mhm.
to the 9th power, but the other two I'm confused about.
Listen here. 7 billion nanoseconds would be the same as hold on. Okay, sorry. No, sorry. It's going to be the other way around, sorry. My mistake there, sorry. Milliseconds. And okay, this was going to be, sorry. So it's the other way around, sorry. Sorry, my dear. Okay.
All right. still don't get how you got those two. Are you,
That's mainly as okay, just the same as your 7 seconds. Just expressed differently. Because we said, okay, they asked about nanoseconds. But if they asked about microseconds, then your answer would have been 7 million. If they said milliseconds, your answer would have been 7,000.
okay, now I get it. I thought you was
Okay.
converting. Okay,
Okay.
thank
Question 19. Okay, now letters below represent the abbreviation for the prefixes of the metric system. Select the select the sequence that appears in a decreasing order. And what did we mean by a decreasing order? That means okay, we start big and go low. Clear? So it's going to be giga is G, uppercase G. Mega is uppercase M. Then we have kilo is K. Okay. Then we have hecto. Okay. And hecto is H. Then we have deca, which is DE. Then we go deci, which is lowercase d. We go centi, which is C, lowercase. Then we go milli, which is lowercase m. Then we go micro, which is mu. And then we go nano, which is n. So these are the abbreviations. So if you look at the first one, M, lowercase, it's milli. Then you have K, which is for kilo. It can't be decreasing order. Because, okay, it started from a smaller and then it went big. At quite a jump. And from there, just go to mega. Then I go to giga. Then I go to deca. So it's not. Clear? Option B is okay. We start giga. Then we go milli. Okay. Then it goes kilo. Okay. Then it goes deci. So it's jumping all around. Clear? Then we go as okay, option D. Mega, kilo, deca, and centi. So that was the only one that actually is okay, started from is okay and went okay this way. Okay, in a decreasing order. Clear? Now, just another way of asking is okay, match the following prefixes with their meanings. Now we can mean it says, okay, giga, sorry, was 1 billion. Mega is 1 million. Kilo is 1,000. Right, okay. Hecto, 100. And deca, tens. Deci, tenth. Centi, 100th. Milli, 1,000th. Micro, millionth. And nano, billionth. Okay. Did you guys get that? Question number tick, 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 21. Now, probably something that, okay, you girls will have to, okay, be dealing with. It's especially that, okay, when we talk about things which are going to be as, okay, reciprocals to one another. Okay, not only related, but universally, not only universally related, but reciprocal to one another. And I mainly say, yes, okay, I briefly mentioned that yesterday. So the reciprocal for nano is a giga. Because that's okay, we can say it's okay. If you look at a nano, it is a billionth, which mainly means, okay, just means 1 over a billion. Where a giga mainly is, okay, just was a plain billion. So billion and 1 over a billion are reciprocal. It mainly makes that's okay, a nano and a giga reciprocal to one another. Clear? So if something is expressed then, okay, as XYZ nanos, anything that's going to be reciprocal, I have a reciprocal relationship to as, okay, this factor over here is going to, as, okay, have a value in gigas. Or something that will be equivalent to that amount of gigas. The reciprocal of kilo is milli. Yes, okay, just look here. A kilo was 1,000. A milli was 1,000. So this was 1,000. A milli was 1 over 1,000, right? Which are reciprocal. You multiply them, and okay, yes, the result becomes 1. But if something is expressed as its unit is going to be expressed in kilos, the factor or number or variable which is going to, yes, okay, be reciprocal to this fellow here, its unit will be expressed in millis or something that will be equivalent to that. So this fellow here is, okay, that's an important one. Okay. Macro, well, okay, macro is just, okay, it just means large or big. Clear? Okay. And micro. Now, if you just look at micro, what was micro? That was 1/1,000,000. And that is reciprocal to a mega, which was 1,000,000. If you look here, million is mega, micro is 1,000,000. So maybe that's okay, just to confuse you, that's why they wrote, that's why they put in the macro. Okay. Now micro is small, small, small. Macro is actually, that's okay, big, big, big. Clear? Or if you say it's okay, microscopic versus macroscopic. Now, why would something be as okay? Why would something be considered microscopic? How do we define microscopic?
Something that we need to use a microscope to find,
To see, and why would you need a microscope?
because it's not like you can't see it with our own eyes. We need to zoom in.
Exactly. Right. Okay, so yes, okay, anything that is not visible by your naked eye, as they call it, okay, is going to be considered, is going to be defined as microscopic. Clear? Okay, whereas macroscopic, anything that you can see with your naked eye, that you don't need as okay, a magnifying glass or a microscope or whatever. Clear? Okay. Did that make sense? So that becomes macroscopic. So that's just the opposite of micro. Yeah, okay. But here the mean is okay, you say, okay, what is the reciprocal of mega? Well, you can be asked about as okay, the reciprocal of any of the other things. So what is the reciprocal of hecto?
Centi,
Centi, exactly, very good. Okay. Okay. So what is the reciprocal of nano?
Giga.
Giga, very good. Okay. Reciprocal of kilo?
Millie.
Milli, exactly. Right. Okay. Reciprocal of deca?
Deci.
Yes, exactly. Okay. Good. Now this one here is a little bit weird, but okay, let's just see. How can the volume of an irregularly shaped object be measured most accurately? Now, what will be an irregularly shaped structure? Go out in your backyard or garden and okay, let's find any bigger or smaller piece of stone. You're going to be, okay, very lucky if you find a stone or a piece of rock that is smooth and round and equally distant as okay, had equal distance measurements across all dimensions. Here. Now you can maybe just okay, just pop that stone into yes, okay, a container of water and maybe just okay, just look how much the film of liquid raises, and that will tell you the volume of that irregularly shaped structure. Did that make any sense? or not? This is what you found in the garden. You want to find the volume of it. Now, what was volume? Yes, okay. A three-dimensional distance. You have a container. It's filled up with water. Let's say, or any liquid. And let's say it's okay, here it is. Filled up to 100 cc's. Now you drop this fellow into, yes, okay. And what's going to happen? It's going to, yes, okay, displace the water and mainly, yes, okay, cause it to raise up. And let's say it's okay, it raises up to, it's okay, a volume of 110 cc. So what can you say that the volume of this rock here was? 10 cc's. Clear? Visual inspection, yes, okay. If you have a measuring glass or if you have a measuring tape in your eyes, then okay, yes, that could be the case. The reason that weight is the wrong answer is that they're not asking you about the mass. They're asking you about the volume. Okay, by ultrasound scanning. That's not going to help you. That's only as okay if you see as okay structure shaped and whatever is okay. Then you can measure it. Clear? But here's okay, you say it's okay, an irregularly shaped object. Like this. Okay, ladies. Now, this was your chapter number 1. And we can say it's okay, the related materials to it, right? Okay. Okay, or as the chapter says, basics. Now we're still going to be as okay, continuing on basics. Okay. But okay, what you mainly as okay will need to as okay, make sure that you understand from this chapter here is what are the kind of relationships. Clear? What does it mean to be directly proportional? Inversely proportional? And if you say inversely proportional, what would it mean to be reciprocal? Okay. So if you are not on top of that, just okay, what you will have to do as we proceed on, because it's going to say is okay, this is directly proportional to this. This is inversely proportional to that. This is reciprocal to this and that. And if you don't know, it's okay, well, you have to go every time it's okay, flip back to chapter 1 and say, okay, what did it mean to be it's okay inversely proportional? What did it mean to be directly proportional? What did it mean to be reciprocal? Clear? And okay, as the units, what do you mean by mega? What do you mean by giga? What do you mean by kilo? What do you mean by a hecto? Probably not. Centi, milli, micro. Those are the main units that we will come across. Okay, so mega, kilo, centi, milli, and micro. That will be as okay the major units that you will be coming across in the book as we proceed. Did that make sense? Okay. But then you will have to know as okay, if something is expressed in megas, what's going to be its equivalent in kilos? What's going to be its equivalent in centis and so on. So, right? Okay. So that's the main. It's okay. It's okay. You can say it's okay. Takeaways from this chapter here. Now, any questions? So if you were able to, yes, okay, answer, yes, okay, the questions by yourselves, you should be good. And yes, okay, if you are able to, yes, okay, follow along when I say, okay, this is the answer that is given, which was not the right answer. But if the question had asked this way, then this answer, which now was wrong, becomes the right answer. If you caught that, you should be good. Okay. Any question, girls? Any relationship on that you still don't get? No? Bon appetit. And are you girls up for starting chapter 2? Don't look away.
Yeah, sure.
Yeah, sure. Okay. Then we will start off with chapter number 2 when we come back after lunch. Okay, where we made as okay, we just talk about generally about as okay sound, not necessarily ultrasound. Okay, just sound. So I see you girls at 12:50. 50, yeah, okay, that's fine. Okay, girls. Welcome back. Okay. Any questions? Anybody want to say something? Good. Then I guess we can, yes, okay, start with chapter number 2. And chapter number 2 is mainly going to be about sound. So, and here goes, that's okay, just keep in mind right now, we're not talking about ultrasound yet. Okay, it's mainly, it's okay, just general sound. Okay, ultrasound is just going to be as okay, a form of sound, if you want to put that. And why we call it ultra, we get to that later on. So first of all, it's okay, what is sound? Now sound is mainly as okay, just going to be as okay. It's a form of energy. Okay. So it's going to be as okay, a form of energy. Okay. And okay, as this form of energy here is okay, mainly it's going to as okay, travel in, we can say it's okay, in the form of waves. Very mean is okay, call these waves, then just becomes what we commonly call sound waves. Okay, as we start talking of yes, okay, sound waves and ultrasound and so on, so on, so you actually will see me as okay, making a sound wave or drawing a sound wave, like something like this. Okay. But basically, as okay, what it's going to be is that okay, yes, energy that okay, as travels from this point, or from here, back here. Okay. Now, two things that we will as okay come across, and especially as okay again as okay as we talk of ultrasound. Okay. But as me as okay going to be as okay, two requirements for as okay a sound to as okay first to be produced and to travel. The first mainly is okay because we can say it's okay that sound is a form of energy. So yes, okay, word mainly is this okay will be needing is a source. Any sound that is going to be produced, or most likely as okay, any energy that is going to be produced will need a source. Okay, energy doesn't come out of nowhere. There is going to be as okay, something that produces it. So whatever is okay produces and form of energy is going to be as okay what we call a source. Now, right now, since I'm the one who is talking, what is it that I'm actually am? I'm the source of sound. Because I produce a sound. Okay. Okay. So what is going to be a source? Me can mean as okay. Generally, yes, okay, mean yes, yes, okay. What produces is okay, the energy, which in this case here is okay, is going to be as okay, the sound. Now, when I'm producing sound, I'm the source of sound. Okay, in ultrasound, if we talk ultrasound, the source of sound is going to be as okay, what we actually as okay, we'll call the transducer. That's going to be as okay, the source of the sound. Okay, you may also as okay, from time to time hear me as okay, using the word probe or the transducer. Okay. How it produces the sound, we will talk more in detail about that in a later chapter. But basically, it's okay, the component of your ultrasound system that is going to be as okay, the source of the sound, where the sound is produced, is going to be as okay, your transducer or your probe. Clear? Will that be mainly as okay, that joystick that you'll be using as okay to apply on the area that you are scanning. Did that make sense? So this is mainly as okay, going to be as okay, where the sound as okay will be produced. It's produced here in the probe or transducer. Now goes what we also say is, well, okay, yes. That now sound is okay, travels in the form of waves. And as many as okay, going to be two characteristics that will just okay explain the type of waves that your sound waves are. First is going to be as okay, we can say as okay that they're going to be as okay be mechanical waves. Now, what does it mean to be a mechanical wave? Now we can say mainly says okay, here is okay. Or let us do it this way. When I'm talking, how is it that you girls are able to hear me? Whether sitting on Zoom or yes, okay, in a classroom. What I actually am doing as I speak is that I actually is okay, particles in front of my mouth actually are put into a vibratory motion. Okay. And it's actually going to be as okay, this motion of particle back and forth to actually cause the sound to travel in this direction here in the form of waves. But the reason that we call sound wave a mechanical wave is mainly as okay because it would need a medium to travel through. Now here goes as I'm talking. The medium is the ear. Now we don't necessarily see particles in the ear, but they are there. Okay, so yes, okay, sound waves is mainly as okay, a mechanical wave mainly as okay because it will need a medium to travel through. But it's actually going to be as okay that because it's okay back and forth motion of a particle then we can mean that a particle was here, but it moves this way, then it moves this way. So it means, okay, moves back and forth like this. Okay, but it is mainly as okay due to as okay, we can say it's okay. Particles in the medium that travels, that moves, and actually that's okay, causes the sound wave to travel. So mainly because it's just okay, sound travels due to the motion of particles. It is considered to be a mechanical wave. Right? Did that make sense?
Can you say that again? You said the back and forth particles in the medium travels and moves.
Listen, okay. It's going to be because a particle is going to be moving back and forth, back and forth. And that's mainly as okay, how the sound travels like this. Clear? So it mainly is okay. The main thing is that it's a mechanical wave mainly because it needs particles that actually it's okay, can move back and forth. So mainly because it's dependent upon particles on a medium to move back and forth. That's why it's okay, sound wave is referred to as being a mechanical wave. Clear? Did you get that, Shaq?
Yes, thank you.
Right, okay. So in that place, so we don't really see it. You don't really see a sound wave, but it is actually as okay, this particles going this way, like back, 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 back. And what is it that they do? They transfer the energy over. Which means it's okay, there's going to be as okay sound. Did that make sense? But that transfer is only possible because right now, yes, okay, I'm in an area where there is a medium. It's gas, that's fine, or air. It's still a medium. Clear? Okay. I can even submerge my head underneath water and be talking. You may just hear me more like, okay, speaking like SpongeBob. Blah, 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 blah. Okay, or that kind of sound. But still is going to be sound. Clear? Okay. I may be standing on the other side of a door made out of wood or any material, but you'll still be able to hear me. Maybe not that clearly, but you still hear that, okay, somebody out there either walked by, okay, as hammering a nail in the wall or something like that. You still hear that sound. Did that make sense? Why? Because, okay, that sound mainly as okay, or sound mainly as okay, the main thing that it needed was, well, okay, a source of sound. That's what going to be whatever produces the sound. And okay, it's a medium through which that sound will be traveling. And what's going to be a medium? Any area or space which has any kind of particles. Yeah. Okay. And that's why it is said that, okay, yes, sound does not travel in a vacuum. Because what is it that you have in a vacuum? It's a space, it's an area, it's whatsoever, but there are no particles. So since there are no particles, but you will not get the sound. Why? Because there was no particles in the vacuum around me. So you can say, it's okay, transfer that energy and make that energy able to travel. So any mechanical wave will need particles to travel. Clear? So sound is okay as a mechanical wave mainly because it can only travel in medium where there is particles. Visible, invisible, that's not the correct. That's not the discussion here. Clear? Did that make sense? So sound is not going to be able to travel in a vacuum. If I'm placed in a vacuum container, this will be what you will experience. I may be knocking, I say, take me out of here. Okay, girls? Clear? So pretty much okay, as based on that. Yes, okay. Sound wave is a mechanical wave. Now I said I was the source of the sounds, and I was the one who's speaking, or whoever is speaking is going to be as okay, the source of sound. Right? Okay. In ultrasound, our source of sound is the transducer. That's going to be as okay where the sound is produced. What we in ultrasound is okay, mainly as okay, we'll just consider to be as okay the medium. Sorry. The medium in ultrasound, that is going to be as okay the tissues. What tissues? We can say it's okay, tissues of the human body. Clear? So that's as okay, what we as okay later on we as okay refer to as medium. Okay. So probably as okay now goes in the next chapter. Okay, primarily as okay if you come across the word source. That will mainly as okay. In most instances, okay, it will mean the transducer. In some cases, or for some parameters, it is going to be as okay, we can say it's okay, the ultrasound system, which is going to be as okay, that big piece of equipment. Clear? But whenever it's okay in the next chapter, when we come across the word medium, that will mainly mean tissues. Okay, so once sounds are being produced by a source, okay, they mainly is okay, will just be traveling through the medium. Now, an ultrasound was mainly going to happen is that, okay, as at different levels, sound waves are going to, as okay, return back to the transducer. It will then be sent to the system, and the system is okay, then make you a picture or an image of, okay, as the area or tissue that you were scanning. Did you girls get that? Okay. So in ultrasound, the source is going to mainly as okay, be as okay, either the transducer and or the ultrasound system. Whereas the medium is going to be nothing but the tissues. through which is okay, the sound waves produced by the source will travel. And okay, as different depths return back. And ultimately it's okay, produce an image. Did you girls get that?
Yes.
Good, thank you, dear. Now goes another thing is and we may ask ourselves, okay, sound is produced by source. Any source. Clear? Okay. And it may, as okay, travel through a medium. Now, mainly speaking, yes, okay, we have, yes, okay, three types of media, depending upon their nature. One is going to be solids. Things such as bones, etc., right? Okay. The next thing is going to be liquid, such as blood, urine, etc., any fluid substance. And the next thing is going to be gases, such as air. These are, yes, okay, three different natures of medium. At least, okay, as if you talk about, as okay, which can transport or which can transmit sound. Clear. We exclude the vacuum here mainly because, okay, first of all, vacuum is not a medium. Vacuum is mainly as okay, just completely empty from particles. And okay, we exclude it here mainly because, okay, what we needed for sound to travel was particles, which we only found in gas, solids, gas, and liquids. Now go, just keep this one here handy because in solids, that's where it's okay. It may sound crazy, but that's actually it's okay going to be as okay where sound travels at the fastest speed. Whereas in gases goes, it's mainly as okay going to be as okay at the slowest speed. And liquid is just going to be as okay in between. So you can say it's okay if a sound was produced by a medium, by a source, sorry. Okay. And was traveling as okay through three different media. You can say it's okay solids. We could say it's okay in the solid, yes, okay, it may travel at a speed of less, it's okay, 300 meters per second. Whereas, okay, if you said liquids, in the liquid, it may travel at a speed of, let's say, it's okay, just 100 meters per second. Whereas in gases is going to be as okay slowest. And we could have said, well, okay, then it would just be as okay 5 meters per second. Although, yes, okay, it is produced by the same source. Okay, could it be as okay an ultrasound transducer? It could have been any person. Saying anything. But in the solid, just okay, that sound when it hits the solid is going to travel at a faster speed. It will travel slower as okay once it hits a liquid. And it's going to travel even slower or at the slowest speed once it travels through a gas. Did that make any sense? So if I asked, or if it's okay, you'd be asked, through which medium will the sound travel fastest? An iron bar, a bottle or a bottle of Coca-Cola, or helium. It will
Iron
travel
bar.
fast through. Yes, Maria?
I said the iron bar.
The iron bar, exactly. Okay. Because that's okay, that's solid. Okay. Any questions? So first of all, sound was a form of energy. Clear? Most sounds are, most forms of energy is okay, will require a source. Okay? So most or all energies is okay, will require a source. Sound was just one form of energy. The other forms of energy, heat energy, for instance. Okay. Now, a big source of heat energy is the sun. Well, that's okay. It also is okay, provides us with another form of energy as well, which is light. Clear? You can compare the moon and the sun and say, it's okay, both of them produce light. But does the moon produce heat? No, not. Clear? So, yeah. You have magnetic energy. Okay, you have kinetic energy. You have potential energy. Okay. So all yes, okay, different forms of energy. Okay. It's not going to be all of them that will travel in form of waves. Okay. So now sound was a mechanical wave. Why? Because it needed particles in the medium. And that mainly is okay, makes it unable to travel in a vacuum. Now goes what pretty much happens that makes just okay a sound wave, or we can say it's okay sound energy to travel in a medium. Is mainly okay going to be as okay the relationship between the particles. Now here. And here. We can mainly says, okay, this is mainly as okay, just 3 groups of particles. We can mainly say that, okay, here, this is group A. But now, yes, okay, this one here is group B. And this one here is okay, will be group C. Now, what we mainly can see here that, okay, as these 2 particles here are close to one another. So that is going to be referred to as that they are compressed. So yes, okay, if you look at the 2 red ones here, they are also close to one another, so they as well also are compressed. Yeah, likely these 2 here as well are also as okay close to one another, so as okay they are also compressed. Whereas if we now look here, the relationship between this green particle and this red particle here is that they are far away from one another. Likewise, this red and this blue here is okay, they are far away from one another. So that is going to be as okay being what you can call rarefied. Yeah. And that might be as okay, that not that might, there is probably as okay going to be considered as okay other groups of particles here and so on. Okay, but goes what mainly as okay happens during compression is, let's say that okay, yes, in this case, yes, okay, our source of energy is over here. Somebody's talking. Clear. And as he or she is okay, produces sound, what is it that he actually is doing? Transmitting energy. And it's not mainly as okay, what we mainly needed was that okay, as these particles here actually is okay, were being thrown into this back and forth motion here. So, but mainly what happened, this particle here is okay, carries energy. It will transfer over to this one here. And what now then will happen is that okay, yes, this particle is okay behaving here. This other green one here gets over here. Pretty much okay, as close to this red one here. Okay. This red one here had already as okay, we can say it's okay, already transfer energy onto the other red one, which has mainly as okay gone over here. And actually it's okay, now it's going to be as okay compressed to this blue one here. Where this other blue one here more proper has okay as been sent over here. So what is it that we see now? Is that okay, as the 2 particles which first were sorry, where were okay. We can say it's okay. Compressed. Now I rarefied. The two particles which were compressed up here are now rarefied. And likewise, okay, the two particles which were compressed up here are now rarefied. And what happens? This particle here, mainly as okay, will just transfer energy onto this particle. This particle here remains okay, just transfer energy over to this. And this one here will have transferred over to another one. So we can mainly say that, okay, yes, the actual transfer of sound energy happens or is at the max when particles are compressed. But what mainly as okay, just will happen then is that, okay, as these particles here, they will move back and the greens become compressed, the red will get compressed. And we can say it's okay, or blues will get compressed again. So the main is okay. So again, energy can be transmitted here. Energy can be transmitted here. And energy is okay, can be transmitted like this. And main is okay, put the particles into this back and forth motion. Did that make sense? And that's why we say that, okay, yes, mainly because of this movement back and forth of the particles, that, okay, yes, sound wave was a mechanical wave. Did you girls get that? So what did it mean to be compressed? Well, okay, it's in the word itself. Being close together. What does it mean to be rarefied? Far away. But we can mainly say that, okay, that the actual transfer of energy or sound energy from particle to particle happens when they are close to one another. Clear? That's okay, what was close now is going to be rarefied. But that's okay, I mean, that's okay, just the particle just moves back and forth like this. And carry energy, transfer, carry energy, transfer over. And that's how that's okay, sound travels. Did that make any sense? Okay. So that's why we call it is okay, yeah? Mechanical wave, because it's going to be traveling, yes, okay, as a result of compression and rarefication of the particles. Does anybody have any questions? Any question, girls?
Not right now, no.
Okay. Now goes beside being a mechanical wave. Why was it mechanical? Because as okay, it could only travel as okay as a result of moving particles. So sound wave were mechanical waves. Right. Why? Because it's okay due to the compression and rarefied particles. What does it mean to be compressed? Close. What does it mean to be rarefied? Far away. Now goes sound waves. Can also be referred to as being longitudinal waves. Now, what does that mean? Or what does it mean to be as okay a longitudinal wave? Now, we can mainly say it again. We have a source of energy here. Somebody talking or producing a sound. What did we just say that the particles were going to do? In this case, yes, okay, they were going to move like this. Clear? Right? Now, what makes a sound wave, yes, okay, be a longitudinal wave? That's mainly going to be because, as okay, the sound in this case, yes, okay, it's going to be traveling in this direction. Mainly it's okay because this is where our source was. Clear? If our source was over here, somebody is okay who speaks back. He or she is also, yes, okay, going to be putting, yes, okay, the particles into motion, which is going to be, yes, okay, this back and forth motion, but she's going to, yes, okay, transmit the sound in this direction. Did that make sense? So mainly, yes, okay, due to that the sound wave travels, yes, okay, in the same direction as the back and forth movement of the particles, which is the case that happens in, okay, in sound waves. That's why, yes, okay, sound waves are going to be known as longitudinal waves. Did you guys get that? You may say, then what about somebody who is down here, for instance? Well, okay, yes. He or she is going to, yes, okay, be putting the particle in a motion like this. And in this case, yes, okay, the sound will be traveling like this. Did you girls get that? So we can mean it as, okay, say that, okay, longitudinal waves, when the direction of the wave or the energy travels along the direction of the back and forth motion of the particles, that will be considered to be a longitudinal wave. And sound wave is an example of a longitudinal wave. So it was mechanical. Why mechanical? Yes, okay, mainly primarily because of, okay, yes, that it needs particles in the medium to travel. What's going to happen to these particles? They're going to, yes, okay, get compressed. And also it's okay, be rarefied. Clear? But due to, yes, okay, the back and forth motion of the particles. But the energy of the wave itself is going to, yes, okay, travel in the same direction as the particles moves. Although it's okay, it does go back and forth, back and forth, back and forth. That's why we call them a sound wave is an example of a longitudinal wave. Another kind of wave, then, okay, yes, is what you can call as, okay, transverse waves. Now, you can still say that, okay, yes, even in a transverse wave, yes, okay, we may have, yes, okay, particles, let's say, yes, okay, moving like this. So we can say, okay, these arrows here, okay, they indicate that's okay, the particle motion. Or where we actually is, okay, well, or actually happens in the transverse waves is that the wave will be traveling like this. Let's say that, okay, the source was down here. If the source was down here, the wave would travel like this. Although, yes, okay, the particles moves like this. So you can actually see, yes, okay, that it's in the word transverse. Because what was it that we said that transverse meant when we did medical terminology? Or even, yes, okay, anatomy. Across or through. You can mainly see here that, okay, yes, the direction of the particle motion and the direction in which the wave travels are across one another. Did that make sense? But please keep in mind, go that, okay, yes, the sound is not a transverse. So we can say, okay, sound is not a transverse wave. It's a longitudinal wave. Because what happened in transverse waves is that the direction of the cross, okay, motion of the particles and the direction in which the wave travels crosses paths. Or as your book may say as OKR, perpendicular, which means your mean at a 90-degree angle. Okay. So here is okay, the particles may move like this, but the wave travels like this. Or we can say as okay, the wave travels like this, mainly because as okay, the particles moves like this. Both are examples of being transverse wave, and sound wave is not a transverse wave, because in sound wave, if the particles move like this wave may either travel in this direction, if the source was over here, or it may travel in this direction. But now it's okay if the source is over here. And this is going to be as okay. This is what we call a longitudinal. Here. Any questions?
Just to clarify, the transverse wave is not a transverse sound, but it's just the
No,
way
no, no,
it's
no, no, no,
crossed.
no, 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 no. Listen to it. Okay. You can say sound waves is not a transverse wave. It's going to be a longitudinal wave.
Okay.
Clear? Okay. Because in terms of physics, yes, okay, as I'm speaking, this is how the sound travels. Why does it travel like this? Mainly because the particles move like this. So since that's okay, the particles moves like this and the energy is okay, it travels like that. That makes sound wave a transverse wave. Did that make sense?
Yes.
Good. Let's just assume that sound was a transverse wave. And it will still be traveling like this. Right? The wave will still be traveling like this. But if it had been a transverse wave, had the particles been moving up and down like this. Did that make sense? So if the wave travel like this and the particles moves like this, that would be, yes, okay, an example of a transverse wave. Did you get that, my dear?
Yes.
Good. Okay. Not that you're going to be asked about it, but okay, that's just for the, that's okay. You can say X-ray. X-ray is a transverse wave. Light is still waves, but that's an example of transverse waves. Because, okay, in X-ray, the particles moves like this. But the X-ray travels like that. Yeah, okay, but that's okay. What we will be talking about is mean it's okay going to be as okay trans, that's okay. So longitudinal waves. An example of longitudinal waves is sound waves. What makes it a longitudinal waves? That the particles moves like this and the sound travels like this. Clear? The sound may hit a boundary or hit a wall or something and okay, it come back at me. That's what we will call a reflection. That's when you say, hello, how are you? And you hear your own voice saying, hello, how are you? Because it actually is okay going to be these reflections here that we will need to produce our ultrasound image. How that occurs and what that is going to is okay due to the sound wave. That's okay. We'll talk about that in a hell of a chapter, which will be chapter number 6. Okay. Any question, girls? Does anybody have anything to say?
It's a lot of information.
It's a lot of information.
Yeah.
Okay, dear. Well, I'm trying to go as slow as possible.
Thank you.
Okay, right now, yes, okay, I'm just traveling at the speed of sound traveling through gas. Okay, okay. Please don't make me, yes, okay, go into, yes, okay, iron rod or something like that. Okay.
Okay.
And so what I'm not going to give you guys physical homework today. The physical homework is just read this, okay, on these few points that we talked about. Okay. So you'll find that on page 11. Right now, don't worry about this. Okay, we talk about that tomorrow. Acoustic propagation properties and bioeffects. So page 11 and 13. Those are mainly, okay, the 2 pages that we just did. Clear? Okay, what acoustic propagation properties are and biologic effects are. That's okay. That is the cardiac output. And what do you call it? Stroke volume of chapter 2. Do you guys call cardiac output?
Yeah.
Okay, what was it?
It's the amount of blood pumped in the heart, out of the heart in a minute. Like,
Okay, yeah. So okay, yes, I may assume that, okay, as the other girls may either agree or disagree. But it's okay, these are the 2 that's okay, as many people, yes, okay, mess up at. So we'll talk about those tomorrow. Okay, so this will mainly is okay, just girls, that's okay, brief intro or sound. Clear? So what do we need for sound? Well, sound is a source of energy. Energy doesn't fall from the blue sky. There is going to be as okay a source of it. Clear? Okay. We at a later instance will talk about okay, law of conservation of energy, which mainly says that okay, as energy can't just be produced. Okay. Another thing about energy is that okay, as it can actually okay change its form. And that's what we actually is okay will be needing in ultrasound. Because the ultrasound machine, first of all, is okay, runs on electricity. Okay. We want that electrical energy to be converted into sound. That's what your transducer is going to be doing. Okay. Transducing, or as okay, converting electrical energy into sound energy, so that you don't electrocute the patient. Okay, as you run an ultrasound or do an ultrasound. I don't think the patient will like that. Clear? Okay. So that's okay, energy can change its form. You see the light behind me. This one up here. How does it produce that light? It receives as okay electrical energy, but there's something in the bulb that converts that electrical energy into light. So that's okay, energy can change its form. Clear? And the more lights I have turned on in my living room here, yes, okay, it may get hot because okay, some of that light, or some of those light bulbs may, yes, okay, also produce heat, which is just another form of energy, which came from electrical energy. Clear? Okay, girls. Now, so see you ladies tomorrow, and okay, we'll meet. It's okay, continue on with chapter number 2.
Thank
Any
you.
last word? Huh?
I was just saying thank you.
Okay, any last word of wisdom? Nope. Okay, then have fun.
See you tomorrow. Bye.
Okay, bye-bye then.